Alright, here's some practice on graphing absolute value equations. So once you've completed the Desmos activity, practice these. If you need some help, you can watch the video. Alright, so we want to graph the following. The first thing we want to do is get the vertex of our absolute value function. The vertex is given to you by hk. Well, here, so remember in our general form of our equation, it's x minus negative 2 plus 1. So my h is negative 2 and my k is 1. Here, there's no coefficient in front of the absolute value, so our a is 1. You always want to graph the vertex first. So negative 2, 1. And now we're going to move our a. Here, we can use a as slope. We're going to go up 1 over 1. Continue that pattern all the way off the graph. And then on the left-hand side of the graph, we want to do the opposite. So we're going to go left and up. Remember, absolute values are piecewise. There's a positive slope and a negative slope. So there's our first absolute value equation. Alright, look at another example. Y is equal to 3 times the absolute value of x plus 4. Alright, so hk, so h is negative 4, k is 0. This time my a is 3. So we're going to use 3 over 1. Graph the vertex first. Graph the vertex first. Then we're going to count up 3 over 1. Up 3 over 1. And then do the opposite. Up 3, left 1. Notice that this absolute value graph is steeper because the A is larger. It's a vertical stretch. Alright, hk, so here h is negative 3, and k is negative 3. This time our a is negative 1 over 1. Graph your vertex, negative 3, negative 3. And because our a is negative, we're going to go down and right, until we run off the graph. And then do the opposite, go down and left. Connect our points. Alright, if you'd like to try one on your own, pause the graph, I'll pause the video, and then when you're ready to check, start it back up again. Alright, this one, number 4, you might notice it's a little bit different because we got that minus 2. We need to move it to the other side. So we're going to rewrite this as negative 1 4, absolute value of x, plus 2. So my h, in this case, is 0, and my k is 2. My a is negative 1 4. Graph the vertex, 0, 2. My a is negative. My a is negative, so I'm going to go down 1, right 4. And no more points will fit on the graph. Let's do the opposite. We're going to go down 1, left 4. And here again, I can't put any more points on my graph. Connect. And there's your absolute value. All right, let's go backwards. Given the graph, let's write the function. So, reverse thinking. Okay, so what do we have to have committed to memory? We know that we need the general form of an absolute value, which is as follows. That means I need 2 pieces of information. I need to know what A is, and I need to know what HK are. Well, HK is easy. That's just the vertex. So this goes, what, right 3 up 2. So H is 3, K is 2. And A, I want to count the right-hand side. No matter if A is going to be positive, so my graph is facing up. So I'm going to go rise over run. So 2, 1. So my A is 2. Alright, so now I simply have to plug in the values into the general form. We have 2, absolute value of x minus 3 plus 2. And since I already had the y equals there, there's my equation. But don't forget, you must have the y equals. Or you have the option of saying f of x equals. Alright, let's look at number 6. We need hk, and we need a. This time my h is negative 2 and my k is 0. So negative 2, 0. My graph is facing down, so I know my a is negative. And it's what? 2, 3. So 2/3. So my equation is y equals negative 2/3 absolute value of x minus a negative 2, which makes it plus 2 plus 0. Right, but I don't have to write the plus 0, so there's my best answer. All right, please, if you have any questions, ask in class.